Welcome, Batch 2. Your role now transitions from a Level 2 individual contributor to a Level 3 facilitator. Leadership in analytics requires engineering the environment where data is processed, rather than simply executing the code yourself. To understand this, we need to examine a failure. Following a recent data delivery, a major client reported a catastrophic, unpredicted drop in their profit margins. In analytics, we define this as a variance, a deviation from normal operating parameters. A Level 2 analyst looks at a variance and searches the code for a typo. A Level 3 lead searches the entire pipeline for the systemic root cause. The scale of the profit drop was severe, wiping out millions in projected returns on paper and threatening the client relationship. This dashboard displays the client's multi-year profit trend. Notice the stable trajectory right up until the latest pipeline logic update was deployed, where the line plummets vertically. A lead analyst uses a variance of this magnitude as the starting point for a structured investigation. The immediate goal is to trace the anomaly backward. You start at the dashboard, move back through the pipeline, and locate its absolute origin. Resolving this will test your technical coding ability and the foundational architecture of your leadership. The resolution process begins with observation. This is the formal identification that a severe discrepancy exists in the output. Next is investigation, where we deploy analytical techniques to define the exact nature of the data drop. This leads directly into root cause analysis. We must bypass the symptom, the reporting error on the dashboard, to find the source. We apply the 5 whys methodology, persistently interrogating the system layer by layer until the underlying fault is exposed. This Ishikawa, or cause and effect diagram, organizes these questions. We map our observation and investigation nodes, which direct our logic toward an isolated root cause. Tracing the logic backward eliminated the database as the culprit. The investigation pointed directly into the Python processing scripts. True critical thinking relies on structured methodologies to isolate the node of failure. It removes analytical guesswork from the process. Moving directly into the code environment, the investigation quickly isolated the core failure down to a single decision. Python serves as a framework for logic. It requires explicit categorization of every data point before processing begins. This side-by-side code comparison reveals the error, calculating profit margins using integers instead of floats. Integers only count whole numbers, truncating decimal points from the dataset. Dropping this fractional data across millions of rows accumulated rapidly, creating a massive false financial loss. The issue compounded as comparison operators, the less thans and greater thans, process the truncated members, causing subsequent logic checks to fail. Finally, logical operators, specifically and or statements, were misused to pass the corrupted data forward into the final dashboard. A misunderstanding of variable types breaks the code, and in doing so, it alters the reported reality of the business. Code does not write itself. The investigation must shift to the human element to analyze why the analyst chose the wrong variable type. The junior analyst responsible had a purely IT-focused background, possessing syntax skills but lacking domain-specific business logic. Knowing that financial margins require decimal precision is a business concept, not a programming rule. This Venn diagram maps an IT pure background against business domain knowledge. Integrating different professional backgrounds allows the team to catch domain-specific errors. A team with varied experiences provides a safeguard, catching contextual errors that a technical specialist might overlook. The ultimate failure belonged to the lead analyst. They assigned a complex financial task randomly, without assessing the junior member's business context. A lead must choose between the specialist approach, assigning the best SQL coder, and the growth approach, assigning a junior a new tool. Handling precise financial variables should have been categorized and monitored as a supervised growth task. When a standard is missed, the lead must provide a feedback loop, identifying the deficiency and providing a strategy to overcome it, rather than rewriting the code for them. Bad code rarely occurs in isolation. It emerges as the final symptom of poor delegation and a lack of inclusive team design. This matrix outlines the responsibilities of a lead analyst: syntax and logic, problem solving, and human coaching. You monitor 3 performance standards. First, data integrity, ensuring accurate output. Second, code efficiency, verifying optimization for large-scale data. Third, deadline compliance, meeting client-driven milestones. Technical logic, critical problem-solving, and team coaching function as a single, inseparable unit. A Level 3 analyst engineers a system where human diversity and strict code logic protect each other from failure. This interface represents your practical application for Task Sheet 2.1-1. Your objective is to build your first logical tool, the BMI calculator. Apply the Variance Autopsy lesson to your workflow. Critically evaluate the specific variables needed before typing any syntax. Determine whether calculating human height and weight requires precise floats or broad integers. Then utilize Boolean logic and operators to accurately categorize the final results. Step into the interface and orchestrate the logic with the precision of a lead analyst.